This video and the two that follow it are complicated. I'm not going to lie to you. This is some difficult stuff, but let's do it, see how it goes. When someone says stability or atmospheric stability, what they're talking about is the likelihood that a parcel of air, however big that parcel of air is, a bubble of air, will rise. An air parcel can be classified as either stable or unstable. We classify an air parcel as stable when it meets these criteria. It's the condition of a parcel when it's colder than the surrounding atmosphere and resists the tendency to rise. We classify a parcel as unstable when that parcel is warmer than the surrounding atmosphere and is buoyant with a tendency to rise. Keep those two terms and classifications close by. How do we determine this? In other words, how do we determine that a parcel of air, a bubble of air that's moving independently through the atmosphere is stable or unstable? We do it by comparing the temperature of the parcel to the surrounding atmosphere. Now, I know this sounds in some ways counterintuitive, but it's a little bit like this. If you take a teaspoon of sugar and stir that into a cup of coffee, it's going to dissolve, and other than tasting it, you're not going to be able to see it. But if you take a teaspoon of olive oil and stir that into a cup of coffee, the olive oil is going to maintain its olive oilness, and it will not mix with the coffee. Within the atmosphere, because it's a fluid body, there are bubbles of air, parcels of air, air masses that are able to move around and maintain their own integrity without mixing with the rest of the atmosphere. This is basically what we are talking about. Take a look at this cumulus cloud that we've seen multiple times. I think you would recognize that the relative humidity inside that cloud is 100%. And the relative humidity just 10 feet away from that cloud is something less than 100%. How do we know that? Because there's no cloud forming 10 feet away from the cloud. You have to have 100% relative humidity in order to make the cloud. So if the atmosphere can maintain different relative humidities, different amounts of moisture, then it certainly can maintain different temperatures. And I'm here to tell you that cloud has a different temperature than the air that's outside of it as well. So what we do is we take a look at whatever the temperature of the bubble is. Let's say it's that cumulus cloud there. And we compare that to the temperature of the air that's around it. So what I just did was I took that cloud, a parcel of air, and now I turned it into a diagram. The parcel of air is that gray bubble in the middle with temperature question mark. The rest of the atmosphere is the blue that's around it with the two temperatures question marks. Okay? Is the parcel of air warmer or colder than the surrounding atmosphere? Well, let's practice it first. So take a look at the parcel of air. We know it's 58 degrees. The surrounding atmosphere is 70 degrees. Ask yourself this first question. Is the parcel of air warmer or colder than the surrounding atmosphere? Obviously, the answer is good, colder. And if the parcel of air is colder than the surrounding atmosphere, go back to the definitions. Is it stable or unstable? Answer is stable. And if the air is stable, what is its tendency to do? What does it want to do? Colder air wants to subside. Very good. Now let's try this one. Now the parcel of air is 80 degrees and the air around it is 70 degrees. Is the parcel of air warmer or colder than the surrounding atmosphere? The answer is you over there. Good, warmer. Look at the definitions. If the parcel of air is warmer than the surrounding atmosphere, we would classify it as unstable. Very good. And if it's unstable, what is its tendency? To rise or subside? Answer is rise. Very good. That's step one.